All right, everybody, we're going to be working on Algebra 1 5.1.3, two variable systems graphing. So we're going to solve these systems by graphing, and we're going to be straightforward. It's going to be easy. Jump right into the checkup. Is the solution to any system of equations where the lines intersect? Where do the graphs intersect? Well, they intersect right here. So I'm going to kind of draw it up on the x and draw it over on the y. So they intersect at this point there, which is 4, 5. I just find the point where they intersect and I'm done. Over here, it's going to be right there, right? That's where the two graphs intersect. It's -2, -1. That's it. That's all we got to do. We just got to find out where the graphs intersect, and boom, there's my answer. All right, now this next one, they want us to graph each, yada, yada. Well, I'm not asking you guys to graph um, like by hand. We have Desmos, we have technology. That's what we're going to do. Use this, what we're going to do. All right, so I have Desmos pulled up over here, and I'm simply just going to type in, for question 3 of the equation, I have y equals x plus 1. It gives me the first graph, right? Graphs it right out for me. The second graph is y equals, I hit the division bar first, 1 over 2, x plus 3. Awesome. Oop, boom, they intersect to 4, 5. This actually might be the same graph. So 4, 5 after we sketch it, after we graph it. Let's go to the next problem. 4, right? Alright, so y equals x minus 2. Y equals negative x plus 4. And where do they intersect at? Well, they intersect at 3, 1 right there. That's where the two graphs intersect. I kind of hover over it. It gives me the order pair. And that is my answer. So if they ask us two graphs, just jump on Desmos. You know, I'm cool with it, and I'm kind of I want to make the decisions here now. I know this isn't always going to be accessible. I know you probably had to graph it by hand during the school year, and I think that's great. I think it's good to know how to graph and how to sketch. You know, we don't need a perfect graph. Just have a general idea of the direction and look of a graph by looking at the equation. Um, but we've kind of already done that, and now let's make our life a little bit easier. All right. Now I'm going to skip 5 and 6. I'm going to come back to them, but I'm going to skip them for now. I'm going to go to 7 and 8. So identify the number of solutions, 0, 1, or infinite for the systems of equations. Since we're talking about graphing, I'm going to use graphs, right? So we could do this algebraically, but I'm going to go ahead and do graphs. That's what we're talking about. So I graph the first one, y equals 2x minus 7. I'm going to graph the second one, y equals 2x plus 13. All right, now if I look at this graph, do they ever intersect? If I keep going, if I get water, they get closer, but they're not really closer. Just it's a different spread. Look, they're below lines, right? So they never intersect. So that tells me we have 0 solutions. Let's go ahead and do the other one. So we're going to have y equals 2 parentheses 3x plus 3. Cool. And we're going to do the other one. Y equals 3 parentheses 2x plus 2. Hey, what happened? Where'd my blue graph go? Oh, I unchecked these to hide them. Do you see how this is the exact same graph? All right, since they're the exact same graph, that means all the solutions are solutions, right? Every point on the graph is a solution. This is infinite. When they're the same line, it's infinite. So when they were parallel and didn't intersect, that was our 0. When they're the same line as infinite, then we did on the other side when you had 1. Oop, is when they just touch and intersect once, that's one solution. All right, let's go down. Write and graph a system of equations to answer the question. All right, this should be fun. All right, Ariel and her friends purchased some drinks and pizza slices at the snack bar. Each drink cost $2, and each pizza slice was $4. They purchased 9 items and spent a total of $28. Write a system of equations to represent the situation using D to represent the number of drinks and P to represent the number of pizza slices. So, first thing I'm seeing is that they purchased 9 items total. Well, however many combination of the items, they spent 9 of them total. And since they're only buying drinks and pizza, right? They're only buying drinks and pizza. I know the number of drinks plus the number of pizza slices is going to equal 9. They bought 9 items. The items could only be a pizza slice or a drink. So D plus P equals 9. That's my first equation. And then they spent a total of $28. All right, so we know our next one's going to be equal to $28. So that's my second equation. Now, what did they spend the money on? Well, however many drinks they bought cost $2 per drink. So it's 2 times D. It was each drink cost $2, so I just do 2D. Each pizza slice was $4 plus 4D. So if you ever multiply this, however many drinks or pizzas, oop, I made a mistake there. That should be a P. Boom, right there. So however many pizza slices and drinks they had, the cost would be $28, but the total number of items was 9. Those are the two equations that I have. So I took they purchased a total of 9 items. So I was like, oh, well, what were the items that they bought? Well, they only bought 2 different ones. We know that the sum of those must be 9. And we know that they spent $28 and they told us what each item cost. So we just multiply it, right? If I know that it's $4 for every pizza slice, I can easily find out how much I'm going to spend depending on how much I want to buy. If I want to buy 5 pizza slices, it's going to be $20. 4 times 5, right? So it's just multiplication. We write it up. Now, graph the system of equations. Use the graph to identify the number of drinks and pizza slices purchased. Now, before we can go into Desmos, before we can do this, we have to switch our variables. I know they asked us to use D and P, but Desmos doesn't recognize D and P, at least in my experience. So we're just going to switch to X and Y. So X is going to be my drinks, and P is going to be or Y is going to be my pizza. So I have these two equations now. I'm going to type them into Desmos. So I have these two equations. Where do they intersect? Well, right there. So the ordered pair is 4, 5. Oop, there we go. So ordered pair is 4, 5. So what this tells me is since drinks were my X, there's 4 drinks and 5 pizza slices. That's what they bought. So we bought 4 drinks and 5 pizza slices. There's your answer. All right, now I did say we were going to come back to number 6 and 7, I think, or 5 and 6, sorry. All right, so this one we're not going to need to use Desmos for, is use the tables to find or approximate to 1 decimal place the solution to the systems of equations. So we are given the 2 equations. We have this one, and then we'll have this one. So we'll kind of separate these. Now, we're also given X values. And we know our solution is whenever at the same X value, the 2 graphs have the same Y values where they intersect, right? So we're looking for the ordered pair in which both equations share the same Y value for the same X value. So if I look at -1 here, -1 has 16 and 4, so these are way off, right? So this is way high, this is kind of low, so this can't be an answer. 0, 12, and 6, I mean, it's closer, but again, we're not the same number. 1, 8, and 8, these are the exact same. That's good. 2, 4, and 10, not the same, not the same. So what I'm finding out from this chart is that my answer is 1, 8. 1, 8 is a point on both lines and is where they cross and where they intersect, and it is my solution. For this next one, all right, so they give me all the X values. Now I'm looking, are there any of these the exact same? 8, 7, no, 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 no. So none of these are the same. Where are they closest? Where is it that they're going? Because now we're going to have to approximate and estimate because we don't have an exact one like we had with 5. 5, we had an exact answer. It was easy. 6 is a little bit more difficult. We kind of got to think about it, look at it. So what I'm seeing is that it goes from 1, 1 to 1, 2. This goes from 7, 6 to 7, 2. And this goes from 7, 2 to 7, 4. Right? These are all, the 1, 3 and 1, 4, these numbers are all spread out. 8 and 7 is kind of far away. So it looks like my answer is going to have to be between 1, 1 and 1, 2. So I'm going to estimate, because this right here is my closest, I'm going to estimate that my answer is 1.2 and 7.3 right there in the middle. I'm going to kind of average it out, 7.2 and 7.4. I'm going to put 7.3 right there in the middle. All right, so we're looking for this. Where is it closest together or the exact same, and we're estimating.